Start recording. Yes, please go ahead.
Alrighty. Gunnar Mills, software engineer for IBM. Been working on the project for about 3 years. Maintainer of 5 OpenBMC repositories. And lately, been working a lot on adding new features to upstream Redfish, and that's what I'm going to talk about today, Redfish and OpenBMC. I've given some variation of this talk a few times now. Okay, quick agenda. What is Redfish? Getting started with Redfish, get into BMC Web, OpenBMC's Redfish implementation, and then talk about our Redfish progress, and then get into the Redfish protocol and data model, and get further into the data model with major collections. Okay, so what is Redfish? Redfish is a standard for managing hardware. Redfish group is part of the DMTF, MCTP, and PLDM, a transport and messaging protocol, are 2 other standards being used in OpenBMC that are defined by the DMTF. Redfish is supported by roughly 30 or 32 paying companies, broke into 2 tiers. There's a promoter tier, and then there's a supporting company tier. And it's who you would expect in system management. A lot of the same companies working on OpenBMC. The Redfish group was created in 2014, with the first spec being released in 2015. And Redfish releases are roughly every 3 months, so for a year. And the latest is 2020.3 that was just released 2 weeks ago. And Redfish started focused on servers, but it's grown. Now it can be used as a solution for networking and storage management. And you can find schemas for BIOS, for Fabric, for host interface, switch, PCLE device, zones. And Redfish is working with several partner organizations to further expand the spec. And Redfish was intended to meet the OCP remote machine management requirement, and it's meant as a replacement for IPMI. IPMI was first published over 20 years ago, and it's not kept up with today. From REST, HTTP methods, post for create, get for read, put and patch for update, delete for delete. It uses part of the Open Data Protocol version 4. It can be usable by apps, GUIs, browser plugins, and scripts. It's extendable with OEM, but clearly OEM, so users know that they're using OEM. And it has incorporated a lot of lessons learned in previous standards and interoperability. So enums and strings are more interoperable than enums and integers are more interoperable than strings. And it's 100 plus schemas now, 2,000 plus properties, and most are optional. So there is profiles to define a larger set of required properties, of which the OCP baseline and server profile are the most well-known. There's a lot of tooling around Redfish. The Redfish service validator for checking a Redfish implementation, Redfish tool is a Python 3 command line tool for targeting a Redfish implementation. And then there's also the Python Redfish library. It's a Python 2 and 3 module for management as well. So this is the Redfish service validator run on a recent OpenBMC master. Our current master passes with no Redfish validator errors. We run the Redfish service validator in CI. We're running it against an IBM Power Systems Witherspoon system. And if you're writing Redfish code in BMC Web, make sure to test your code against the validator. Okay, so this is a Python 3 example showing how simple it is to use Redfish, 5 lines of code, built-in Python libraries, token-based auth. This is the computer systems resource, and it's printing the system model. And this wouldn't be much different than calling Google Maps, Twitter, Facebook.com API. Okay, so getting started with Redfish. From the Redfish standard, you can request access to the Redfish forum if your company's one of the 32 members of the Redfish forum. That's the first link. The second link is the developer hub. I use this a lot. It contains links to things like schemas and mockups. The third one is the private repo. So you must be part of the Redfish forum to get access to the repo. And then the last one is a link to the mockup. It's the simple rack mounted server mockup. Okay, so schemas, that's off the developer hub, that second link. And this is just a small set. Redfish is 100 plus schemas now. Okay, and then this is a screenshot of the mockup. These are pretty useful. Redfish spends quite a bit of effort maintaining these mockups, and there's several. And this is a screenshot of the processor resource and its properties you would expect in a processor data model. Things like processor architecture, manufacturer, total cores. Okay, for questions and feedback, a really great place to start is this Redfish forum. Anyone can post. You don't have to be a Redfish member. If you're a Redfish member, a GitHub issue in the private repo is also a place to request a new feature, but even then, most features requests start here. And we have a requirement in BMC Web that before OpenBMC OEM can be added, first that feature must be requested to be added to Redfish, and that's where you would do that. And I would say about 50% of the traffic here is OpenBMC. Okay, talking about BMC Web. BMC Web is our web server. It's where support for Redfish is being added. It's described as a do everything embedded web server. Besides Redfish, authentication, static file hosting for the web interfaces, exposes the dbus interfaces as a REST API for now anyway. Also virtual media and KVM by a WebSocket. And it's configurable, so if you just wanted a subset of those. It uses Boost Beast, moving away from Crow, and it replaces Phosphor REST server, a Python-based web server. And with Redfish, we're adding a translation layer between the dbus layer and the user. So with Redfish, changes to our dbus interfaces do not impact users. All right, wanted to just briefly touch on the OpenBMC releases. The first community release as a Linux Foundation project was 2.6. That was February 2019. 2.7 was August of 2019, and then 2.8 was just a few months ago in June. And the releases are every 6 months following Yocto releases. We missed a Yocto release in there between 2.7 and 2.8. It was too soon after the 2.7 tag. And this is a screenshot of Brad tagging 2.8 in June. So there's a little bit of Redfish in 2.6. 2.6 was February 2019. It included Redfish schemas like processor and memory and chassis. But really the basic Redfish functionality for system management was added in 2.7, which was August of last year. Firmware, logging, network, power state management, multiple user management. And this is the Web UI view GUI using the Redfish API for user management. Okay, so 2.8, this was June, just a few months ago, and this really gives a good idea of our Redfish progress. A lot of basic Redfish functionality in 2.6 and 2.7. 2.8 is getting into more advanced features. All sensors in Redfish allowed us to move the web interface sensor page to Redfish. Auto reboot or automatic retry, as Redfish calls it, is something we drove into the Redfish spec. Event service and subscription collection allows for notifying the client of a resource change outside of the normal request response. Full LDAP and certificate management were new features to OpenBMC. The task and task service schemas are for asynchronous operations for things that take longer, like firmware update, but really it could be for any operation. And this is the SSL certificate page using the certificate schema in the certificate resource. Okay, so what's next? Maybe this is 2.9. Dump and multiple firmware image support have been merged, so they're in master today. Things like boot progress were added in 2020.3, so just need to implement that in BMC Web. Redfish is targeting new power and thermal schemas and this new alarm concept for 2020.4. SNMP alert support. Redfish already has that. Phosphor SNMP is the OpenBMC repo, so it's just mapping that to Redfish. And then there's more work coming around telemetry. Okay, so multiple firmware image support is done via the active software image link. So you would do a patch to change the running firmware image. OpenBMC calls it running or functional. Redfish calls it the active image. And that's what the left shows. The right is the last power operation for the system. Also something we added to Redfish, and this is displayed in the GUI. Okay, so more about the future. Web UI View uses Redfish. Foster Web UI did not, and we'll eventually move away from exposing the dbus interfaces. OpenBMC tool, a command line tool for interacting with an OpenBMC implementation will most likely go away in favor of like a Redfish tool. And we plan to continue to upstream properties to Redfish. And on the left, asking for support for user management groups. Something Redfish said they would accept. It's targeted for 2020.4. That's from that Redfish forum. And on the right is from the OpenBMC mailing list. This is responses to the Redfish dump proposal, which started the process of adding dump support to Redfish. Dump support was added in 2020.3. So talked about this some already. The Redfish protocol. The Redfish protocol's versioned separately. It's versioned off of the service route, which I'll show later. HTTPS, SSL for data transport. Redfish chose SSDP for service discovery because at the time they believed it was the most widely used protocol. It's used a lot in printers and Windows devices. Redfish uses, or the protocol uses HTTP-based alert subscription. And I've included the link of where you can find the Redfish protocol. Okay, so getting into the Redfish data model. So the service route is at /redfish/v1. If there was a v2 of Redfish, it would be /redfish/v2. That's not currently planned. I think they'd only consider it if they couldn't maintain compatibility. Redfish is a hypermedia API, so all resources are linked from the service route. And you can see in the service route links to things like sessions and accounts and schemas. And then Redfish uses the concept of collections a lot. And so that's what these managers and chassis and systems, those are all collections. And those are what I consider the three major collections of Redfish. And it's kind of defined as a system is the logical view from the OS, its memory and processors. Chassis is the physical sheet metal. It contains power and thermal, fans, power supplies, sensors. And then the manager is the BMC. And between all of these is links to show relationships. Okay, so all resources have their schema name and version, and so then you can tie this back to the Redfish schemas. And that's defined by the odata.type, the formats listed there. Odata.id is a self pointer. ID is we're typically using as the last segment of the URI. Status is a complex of 3 properties. State, which can be like 10 different values. Disabled, updating. Health and health rollup, which can be one of 3 different values, okay, warning, and critical. Health rollup is of the resource and its children. Health is just of the resource. Redfish is actually looking at adding a 4th property to status. That would be conditions. It's an array of messages to describe why the health or health rollup is warning or critical. The conditions is something Redfish is targeting for 2020.4 as well. Links, as I kind of mentioned, shows a relationship. So there's a link from the BMC to the chassis and from the chassis to the BMC. And actions, they go beyond what CRUD HTTP operations can perform. Actions can be used to reboot the BMC or boot the system. And OEM is used by vendors, and it's clearly marked as OEM in the path. Okay, so the service route, you can see the schema and the version in the odata.type. This is the service route schema version 1.5. And the schema versions in the format V major version underscore minor version underscore errata version. If Redfish ever adds new properties to a schema, they bump the minor version, so 5 would become 6 if there was properties added to the service route schema. You can see the Redfish protocol version. That's the Redfish version down here, 1.9. And as mentioned, the schemas are all individually versioned, and then the Redfish protocol is separately versioned. Okay, so this is the computer system. This is what I would consider the first major collection. The computer system ID and manager ID are hard-coded in the OpenBMC implementation. The computer system ID is lowercase system. The manager ID is lowercase BMC, but you can't always assume that the ID is going to be the same. Different implementations use different IDs for computer system and manager and chassis and such. Nope, go ahead.
Yeah, thanks. Is this always the case for OpenBMC that under systems the ID is always going to be lowercase system, and for the other collections they're going to follow something similar, like managers will be a BMC? Or is there some change? I was just looking through some of the code and I saw some, or maybe it was documentation referencing maybe some hash symbol inside part of the URI. So I wasn't sure what that was about, but so the idea is that for OpenBMC implementation, this is the way it's going to be implemented and should.
Yeah, so this is the way we currently have it, and there's no plans to change it. So it would be hard coded to system for the computer system ID and hard coded to BMC for the manager ID.
Okay.
It's just if you write tooling for a Redfish implementation outside of OpenBMC, that wouldn't work. I've seen other implementations use like the serial number for the computer system ID. Okay,
yeah, I think others have mentioned before, implementations are all over the place for IDs like this, but when you get to the chassis, I'd also like to ask a question of how that's determined and if it's configurable at all.
It's currently not configurable. I could see if that's something someone needed, though. That could be something that I think upstream would accept.
It's based on frus. I'm probably jumping ahead here, but is it based on frus, or how is that string?
Yeah. So for chassis, it's coming from the dbus object, I believe.
Okay. Yeah. Maybe once you get there, you can talk more about that. That's great. Thank you.
One final thing I wanted to point out here in the system resource, the power state is not a writable property. So a post to the action computer system reset is how you would boot or reboot the host, and then power state would be updated after the host booted. And that's what this one shows. It's showing booting the host, a post to the system action computer system.reset. resets an overloaded term in Redfish. Okay, so chassis contains power and thermal, fans, temperatures, voltages, power supplies, and you can kind of see the links to all these here. Under power would be the voltages and power supplies, and under thermal would be the fans and temperatures. And you can see the links to the computer systems in this chassis and the managers in this chassis. And the properties type is pretty common in Redfish. So chassis type is kind of a human readable enum to give more information about the actual chassis. And this chassis, the last segment of the URI here, the lowercase chassis, I believe that's coming from dbus.
Okay. Okay. Maybe I can ask about this offline, but yeah, if you have any pointers for that, that'd be helpful.
Yeah, I can throw something on IRC.
Okay, thank you.
Okay, so the third collection, manager. So on the left side is the manager collection, of which there's only one member, one manager resource, BMC. And then on the right is that manager resource. So /redfish/v1/managers/BMC. And you can see things like the BMC date time, the BMC Ethernet interfaces, the BMC firmware version, kind of the properties you would expect in a manager or in a BMC model. Okay, wanted to touch quickly here on sessions. Redfish and BMC Web support both token-based auth and basic auth. And this is Postman. It's a development API environment, and just doing a quick basic auth. And basic auth is fine for a quick crow command where latency is not an issue, but since a new session is created for each call, it's not ideal for multiple calls. Instead, token-based auth should be used. And to do that, it requires a client to post with the username and password to the sessions collection to get a token. And this reduces the latency of each call. And so this is the sessions collection, and then below is a session resource. And to delete a session, you would do a delete to the session resource URI, the session service /session/ the crazy hash there. That's all I have for slides. What questions do people have?
So hi Gunnar, this is Vijay. I have a question on the sensors data collections, and you showed that it's done via chassis. Under the chassis, you have power and thermal. So is there a single collection of HDR where single command, I can get all list of sensors?
Couldn't come off mute. Not today. So Redfish actually used the sensor. Let me pull up chassis here. Okay, so Redfish uses the sensors, and this is a post, and I can throw this on IRC, but Redfish says that sensors should only contain sensors that aren't already in thermal and power. That said, for 2020.4, Redfish is targeting pretty much a complete rewrite of power and thermal and fans and temperatures and sensors, and they're going to actually move to what you just described, which is sensors will contain all the sensors, and then power and thermal and fans and power supplies will just point at whatever sensors in this sensor collection here. But today, no.
Okay. So in this slide, you are showing thermal and power are the only collection under chassis. Is there any other collection under chassis?
Can you repeat that?
My question is, right now in this diagram, we are seeing the data collection are only thermal and power sensors under the chassis. Is there any other data type collected under the chassis?
No. So PCIe devices is another collection, and that would have some sensors under it, but it's really power, thermal, and then just sensors would be a collection of everything that doesn't fit under power and thermal.
Okay.
And this is, as I kind of mentioned, this is changing for 2020.4, or they're targeting 2020.4, where sensors will contain all the sensors, and then any thermal or power sensors will just point or have a link to those, to whatever sensor under the sensors collection.
Okay. So another question on, does Redfish support the serial over LAN, the SOL connection?
Yes, it's modeled now, and I think that was new. I think that was 2020.3.
Okay.
Yeah.
Hi, is it planned to implement PCI slot collections?
I don't think we have that support today in BMC Web, and I'm not sure if Redfish supports that or not, I guess. I haven't looked at that feature.
So for SOL, we do not have support in BMC Web yet, right?
Correct, but it's been added to the Redfish spec.
Okay.
So now it's just implementing it in BMC Web.
Okay. And another line is, has Redfish support for multi-host? How is the multi-host being handled in Redfish?
Redfish supports, since system is a collection, you can have as many computer system resources as you want. So that's you can, and there's a system type, and it's at least 6 or 7 different enums for system types. So that's how you would support. You could have multiple systems here. Some could be virtual, some could be, this one's physical, for example.
By the way, saying about fans, how do we handle double fans system when you have one fan with, well, one fan assemble with 2 or more fans in one enclosure?
So within one enclosure is what?
System fans, when you have, let's say, 2 PVMs, 2 tachometers, but it's physically one removable unit.
Okay, so Redfish has some good mock-ups on some of this, like a bladed chassis and stuff. I suspect in the use case you described, you would have like 2 chassis maybe, or maybe even 3 chassis, one that's encloses the other 2, and then you might have multiple systems there as well. And in chassis, the same thing. So chassis is a collection so you can have as many chassis as you want.
This is Mike Jones. I have a question. I work at Analog Devices and have been looking at integration of our PMBus regulators because we have some customers that use OpenBMC. And one of the things I'm running into, it's a potential problem, is that when you separate a sensor service from a power service, and assuming the power service issues some kind of control, it could turn something on or off or change a voltage or margin or whatever during manufacturing. You have the problem that the communication over PMBus is not atomic. So you have this sort of scenario where it requires a page register. And so early on, Intel defined this page plus as a way around this because that's an atomic transaction, but not all parts support page plus. So the difficulty is if the services don't, work together in a way to say, lock a bus so that I can issue 2 commands and then unlock it. Then you don't have, some parts can't integrate because you don't have a way to deal with it. If the sensor and the power control were all in the same service, then it could manage it within its own service. And so I'm just wondering if architecturally, going forward as people integrate, some of the non-VRM type regulators into systems, whether this is just going to become a problem.
I think you cut off there.
Yeah, maybe we missed some of the first part of it. I didn't have my microphone. So I work for Analog Devices, and we're trying to figure out how to integrate our PMBus regulators. So it's a basic fact in the PMBus world. Standard commands that deal with things by pages are not atomic. So it takes 2 bus transactions. So if one service is controlling margin, on, off, voltages, it needs the page register. And if another service is doing sensors and telemetry, it needs the page register. And when they interact, you control and read and write from the wrong registers. So in PMBus is something called page plus, which is atomic. And that can get around it, but not every regulator has it. So when you start dividing these services up so that more than one service is trying to deal with the same PMBus device, unless these services can coordinate with each other through some kind of a mutex so that only one gets to control it at a time, if they're running independently, then they don't interact well. And so if over time people start integrating these PMBus parts, like on boards with FPGAs and other things that are a little bit more general than just a VRM-based design, then I'm just wondering what's the best way to manage it? Should the architecture account for this and put things together that need to be together, or will services just have some kind of way of coordinating access to the bus between themselves?
Yeah, so I don't think the limitation here is Redfish. It's the OpenBMC architecture, and
yeah, it only relates to Redfish as if the interfacing encourages separation of services and then presents the problem. It's not direct.
You went away there a little bit.
I think it's only an issue from a Redfish point of view if its architecture encourages the separation of services that use the same bus by its nature. If it encourages having a service that does on, off, and margin, or whatever, separate from sensors, then it becomes a problem in the implementation.
Yeah,
unless one service is implementing 2 interfaces, I guess.
So Redfish should allow for that flexibility. Redfish overall is a lot of schemas, a lot of optional properties, and allows for a lot of use cases.
Yeah.
A lot of times Redfish is intentionally vague.
Okay.
Any other questions?
The telemetry implementation, when do you suspect that might be complete? Like what version, and then that version, when do you think it might, well, ballpark, right? When it might be released?
So there's starts of some telemetry work now. Some of that's been merged. It's really hard for me to say though on a date.
Okay.
I know from IBM's perspective we do have interest in it, but I think there's other things we're working on now. So.
Okay, so not likely before the end of this year then.
Yeah, I think that's a fair statement.
Okay. Okay, thanks.
So I have another question. I'm also on the PM-Bus committee, and Vivek recently put out into the question on your forums about interfacing for programming devices and system. A lot of our devices have double EEPROM, and some of our big customers, they buy parts from the companies and organization want to push out a recipe that programs parts in the system, and so that will probably require some Redfish interfacing and either a file format that's independent of Redfish, or maybe it's built into the Redfish description of how to program a part. What wasn't clear from one of the responses was, what's the proper way to work with the Redfish community? Is it for us to develop something that we think is workable and bring it to you guys and say, what do you think, and work with you? Or is it better to explain what our needs are and give you abstractions and have you guys work out details? I mean, what's the normal way of interacting? And I know how to interact with where to put questions. The question is, what's the model for putting something totally new in place? Is it someone bringing something mostly baked to you guys and working, or is it making a request and saying, will you do this for us?
I think mostly, so for most feature requests that if it's just a property or something, here's a good place to start. And even things like dump, this is how dump got added.
Mm-hmm.
But someone will have to come present to someone who's a Redfish member will have to come present to Redfish, and probably a PowerPoint where you've have some the new schemas defined, have some mock-ups, have some examples, and then from there, Redfish will probably have feedback, and maybe it's a version 2 of the PowerPoint, a version 3. And definitely there's people in the Redfish community that are willing to help. I've definitely seen stuff where someone will present a new schema or something to Redfish, and Redfish will incorporate that maybe in an existing schema, or if they have plans for also something in that area,
Okay.
they maybe would do the heavy lifting.
So should our organization become a member, or some individual in the organization?
It's you said SM Bus.
Yeah, we're actually called system management, whatever. But we manage all the specs for PM-Bus, SM-Bus. That's all in our organization.
Yeah. So
Smith is their official name.
okay. So Redfish has partnerships with several other organizations, CINA and several other ones. So that might be a route where
Okay.
SM Bus becomes a partner with Redfish,
Okay.
where they can have joint calls and discuss the new schemas or features that SM Bus is looking for.
Okay, thanks. I can pursue that. I'm on the board, so I can influence that.
Okay. And I can help with if you want emails for the chairman or the co-chairs of the Redfish group.
Okay. All right.
I think that would probably be a good place to start in setting up a partnership.
Okay. Thank you.
So is there any service, Redfish service to collect the host data like device informations or system informations or BIOS informations? So do we have any Redfish service which does that?
So what are you thinking, like BIOS attributes or more of the vital product data, the
yeah, more of the data, more of the vital data of the host, like a DIM or system information. What all that, like a device data or system data of the host?
Inventory? Is that what you're
Maybe, yeah, of the host, yeah.
yeah. So I mean, there's phosphor inventory out there. There's entity manager, and so BMC Web would talk to whichever one implements those properties for the system and display those on Redfish.
So will it come under the system of the interface?
I guess I would have to know what properties you're like the model and the serial number and stuff like that.
No, it's like about the host information, right? Like how many DIMMs host has, what is that, what is the BIOS is running, what is the IP address, if the network information, if you can get, what is the IP address of the host, or any other such information of the host, physical information.
Okay, yeah. So I think entity manager would get some of that. Would get the number of DIMMs and the information around the DIMMs. DIMMs are under the system. It's under memory here. It's not shown, but firmware version, that's part of I think it's both displayed here and then it's also under BIOS, the host firmware version.
So the host firmware version are being captured by entity manager?
I'm not sure about that, but for sure the DIM inventory is.
Okay. Okay.
Anything else? Alrighty. Thanks so much. Thanks for setting this up, Sai.
Yeah, thanks a lot, Gunnar. It's very good discussion.
Thank you.
Thank you all.
Very helpful. Thank you.
Thank you. Have a good day.
I'll just wait up for your